All right, the next section we have here is 3.5. Higher derivatives, or higher order derivatives might be a better title, where effectively, once you take a derivative of a function, you can take the derivative again, provided it's differentiable. And higher order derivatives give us different, more detailed information about the curvature of a function, or how it looks, or how it changes. There's also another thing at the end of this section where it's very useful to figure out how to write a general expression for any derivative. You can start with a function, and instead of having to take all the derivatives, you could develop a formula for some functions that are sufficiently well behaved, where you could then say, okay, if I want to know the 9,000th derivative, all you have to do is plug in 9,000 and the formula would spit out the 9,000th derivative for you. So that's pretty neat. All right, so let's get started here. Example 1, we want to find the second derivative of each of the following functions. So polynomials are great to work with. There's not usually a ton of simplification that you have to do along the way. You can just kind of differentiate. So nothing to simplify here. We can, that should be f prime. We do another one, f double prime of t. And here we should have 56, t to the 6th, minus, what's this going to be? 200, 210, t to the 4th, plus 24, t squared. There's our two derivatives. Now, oftentimes, after you take one derivative, it will be necessary, maybe not necessary, but it would be a very bad idea if you didn't simplify before moving on to the second derivative. So here, if we go ahead and take our derivative dy dx, we've got a quotient rule here. So this would be derivative at the top times the bottom left alone, minus the top times the derivative of the bottom, which is 1, so I'll just leave it like that, all over the bottom squared. Now, what we should do here is simplify this. So here, if you notice, if we distribute, we're going to have 2x minus 2. And over here, we have minus 2x minus 1. So here we've got positive 2x. Here we've got negative 2x. The 2x's will cancel. So we'll really be just left over with negative 2 over x minus 1 quantity squared. All right. Now at this point, we can do the quotient rule again if we so choose, but notice how the top is just a constant. There's not any variables up top. So really, quotient rule may be considered a bit overkill. You could bring the entire denominator upstairs by tossing on a negative exponent to it, and then if you go ahead and differentiate to that to find the second derivative, this would be negative 2 times negative 2 is 4. Leave the inside alone, subtract 1 from the exponent, and then multiply by the derivative of the inside, which is 1. That is a lot better than going ahead and doing quotient rule. Sometimes it's a lot worse, sometimes it's a little bit worse, but in general, simplifying as you go before taking that next derivative is always a great idea. Part C. Here, this is function notation, so it's telling us that the variable is s, so we're going to treat a and b as constants, and s is the only variable. So before we differentiate, let's go ahead and just write this as as to the 1/2 plus b times s to the minus 1/2. Then g prime of s is 1/2 as to the negative 1/2 minus 1/2 b s to the negative 3/2. That's the first derivative. The second derivative now, g double prime of s, this is negative a quarter a s to the negative 3 halves minus, but we're going to multiply by this negative 3 halves, so that will be a double negative, so positive 3/4 b times s to the negative 5 halves. And that is the second derivative. This one, we don't have an expression for g of x, so we'll just go ahead and write the derivative of f in terms of the derivative of g. So this is a quotient rule. So this would be derivative of the top times the bottom left alone minus the top times derivative of the bottom, which is 1, so I'll leave it not written, all over the bottom squared. There's not a ton that we can simplify in the numerator, so we'll just go ahead and start working on the second derivative, which is another quotient rule, probably a bigger fraction. So the derivative of the top, the first term in the top, is a product. So a product rule, derivative of the first times the second left alone, plus the first times the derivative of the second, which is 1. So that's derivative of the first term. Now derivative of the second term is g prime of x, so minus that. So that's the derivative of the top. So derivative of the top times the bottom left alone minus the top left alone times the derivative of the bottom, which is 2x, all over the bottom squared. And now we could simplify things because I do see that these two things are going to cancel, and that's nice. But since we're done with our answer, we're not going to go on to find a third derivative, then there's no point. Just finish.